So this is section 4.4, number 21. And so we have a boat sitting out here in the ocean. They want to go to this restaurant. So here's basically the question. Should they go straight to the shoreline, then walk, or take the boat directly to the restaurant, or stop somewhere in between and then walk to the restaurant? Now here are the conditions. She walks 3 miles per hour and she rows 2 miles per hour. She wants to minimize her travel time. So she wants to get to the restaurant as soon as possible. She has a blind date and she heard this guy is really hot and doesn't want to be late. So what shall she do? Because if she's late, this guy might be gone, out of there. So we're trying to find time. We're minimizing time. So we need a formula for time. Time is of the essence. So here's something you should know. If you take your rate times your time, that's going to get your distance, right? Your miles per hour times your hours gives you the total distance traveled. So this here, I should do a different color. Let's do gold. That's not gold. Let's do gold. So that we'll call distance 1. Okay? And then her walking from here to here, we'll call that distance 2. Now we know her rate, we'll call rate 1. What's her rate on the boat? It's 2 miles per hour. And what's her rate of walking? They tell us she walks at 3 miles per hour. Okay. And then the time she spends walking, we'll call that T1. I mean swimming, not swimming, boating. The time on the boat we'll call T1. And then the time that she walks is T2. So we need to get an equation for time, because here's the key thing. Look what you're trying to minimize. Minimize the total time traveled. So I claim that her time formula, because you need a formula or an equation for what you're trying to maximize or minimize, because that's what you have to do. So I'm going to claim her time formula is going to be T1 plus T2. Do you all agree? Nod your head, I agree. Okay, how do you find T1? Well, let's look at the relationship. Rate times time is distance. Rate times time equals distance 1. But what is her rate? It's 2. I don't know T1, and I don't know D1. Now, if I were to solve for T1, I divide both sides by 2. T1 is D1 over 2. I know that. Okay, let's do the same thing. Her rate walking times her time walking equals her distance walking. If I solve for T2, oh, first I got to plug things in. I know some of that stuff. Rate 2 is 3. Her time we don't know, and her distance we don't know. But if we solve for T2, let me move that to the right so it's not so blurry. T2, you divide both sides by 3, it's D2 over 3. Okay, we have more information. We are not done. Because if we were to take this formula and plug in T1 and T2, we're going to be in trouble, because it's going to be this plus that, right? It's going to be D1 over 2 plus this one, D2 over 3. How am I going to figure that out? I have too many variables. Okay, here's where we get some craziness. Are you ready for this? I don't know if you're ready, but watch this. Let me use green. I want a darker green. Let me change the color of that pen. Darker green. There we go. This distance from here to here, I claim that distance is 6 minus d2. Because this distance is 6, you take away d2 and it leaves that. We got that. Now, this is crazy. We have a Pythagorean theorem. This squared plus that squared equals that squared. Do y'all see that? Pythagorean theorem. One more time. This squared plus that squared equals that squared. So 4 squared plus 6 minus d2 squared equals d1 squared. Whew! Let's do more work here. This is 16. If I square this, this is 36 minus 12d2 plus d2 squared equals d1 squared. So what is d1? Let me combine like terms. So I'm going to get d2 squared minus 12d2 plus 52 equals d1 squared. If I square root both sides, I get d1 equals this ugly thing. Now, just to encourage you, as crazy as this problem has been so far, you're not going to have something this complicated on the AP test, okay? Usually the optimizations are more straightforward than this. So as long as you understand the basic process, we're good. If you're thinking like, I would never think of this on the AP test, it's okay, because you wouldn't have to. So let's do this. I'm going to replace D1 with that. Why would I do that? Because I only want one variable. I don't want two variables. I only want one variable. So here we go. T equals square root d2 squared minus 12d. Let me get rid of that. And that's d2 plus 52 over 2 plus d2 over 3. Okay. Wow, that is my formula for time. Now I want to minimize the time, right? So where do minimums occur? Now this goes back to chapter 4, section 1. Minimums occur at critical points and endpoints. So to find your minimum, I need to find my critical points and my endpoints. The critical points, well, we can do this. I can do this. So let me rewrite this as d2 squared. You know what? Just for simplification reasons, I'm not going to write d2. We know, just so I don't have to put all these 2's in, minus 12d plus 52. I'm just being lazy. At this point, we're going to assume that d2 is d. So once we find d, it's going to be d2. And I'll give you more details on this. So let's take the derivative to find the critical points. What's the derivative of t? Well, this one I have box to the 1/2 power. So I bring the 1/2 in front, and then I have box to the negative 1/2 power, but now I multiply by the derivative of the box, which is 2d minus 12, and that's all over 2, plus the derivative of that is 1/3. Okay, let's just keep going here. The derivative of t is, so on the bottom, let's see what we have. We have 2 on the bottom and another 2 on the bottom. So that puts 4 on the bottom. This is a negative, so that's on the bottom. And this 2d minus 12 here, that's on top, plus 1/3. Okay, more work to be done here. I can factor out a 2 from this. I get d minus 6, right? And that 2 cancels with that, leaving a 2. This is crazy, guys. Crazy. And I hope the answer comes out right, because that would really stink if it doesn't. Okay, we need a common denominator. So I wish this one had a square root of d squared minus 12d plus 52, but I can put one on top and bottom, and that equals 1, so I haven't changed anything. So that is bueno. And I need a 6 here and here. So I'm going to multiply this by 3 over 3. And I want a 6 down here. To get that, I'm going to multiply by 2 over 2. Wow, this problem is just never ending. Never, ever, ever ending. And on top, I need to distribute that 3. I'm going to get 3d minus 18 plus square root of d squared minus 12d plus 52. Oh, I forgot the 2. There's a 2 there. Good thing I saw that. Okay, this is getting crazy. Are you ready for this craziness? Okay, what is a critical point? When the numerator is 0, the derivative is 0, so that's a critical point. So let's set this numerator equal to 0. I hope this answer comes out right, because this is a lot of work. And again, just to remind you, you're not going to have anything like this crazy on the test. So just try to follow the concepts. Don't worry so much about the algebra and all the other things that are going on. The big picture is what you want to understand. So I want to get rid of all of that. So I'm going to subtract that from both sides. I'm going to get minus 3d plus 18. I hate the square root sign. So I'm going to square both sides to get rid of that. Okay, I'm tired already. We're just halfway through this problem. So 2 squared is 4. And the square root and square cancel. So we get that. On this side, we get 6 or 9d squared. And 18 times 3 is negative 54, negative 108d. Man, I need a calculator. These numbers are getting big. And like I said, I hope this answer comes out right, because if it doesn't, I'm going to be so sad. Distribute the 4. Yeah.
You made a mistake. You forgot. You put 5 instead of 52.
Oh, it's a 52. Thank you so much. Okay, going back. Wow, this is supposed to be a 52. Okay, thank you. So fixing that, we get minus 48d plus 52. That's 104, 208, I hope. And let me double check some of my math. 18 times 3 times 2, so 108. We're looking good. I'm going to subtract 4d squared from both sides. That's gone. I'm going to add 48d to both sides. That's gone. And I'm going to subtract 208 from both sides. And that's gone. So I get 0 equals 5d squared. Is that minus 60? And what's that? 8, 116? Are you guys double checking my math? Let me double check that. 324 minus 208. Okay. And I don't know if that's factorable. Should I use the quadratic formula? Yeah, that's going to be a big number here. Let me go ahead and check this.
So Yoshida, the 116 should be positive.
Oh, thank you. You guys are saving my life today. I shouldn't have started this question. This question's like mind-blowing. Okay. I'm going to have to use quadratic formula. And hopefully I get the right answer. Okay. There once was a negative boy who couldn't decide whether to go radical party. Because he was so square, he didn't go. I missed out on 4 awesome cookies. The party was all over at 2 a.m. I think the calculator actually has a solver for this. All right, let me check this out. 60 squared minus 4 times 5 times 116. And 1280. We could also get 6 minus this value, so let me do that. Try it again. 6 minus square root of 1280 over 10. And the other answer is 2.422 approximately. This one's ridiculous because, look, the distance is 6. There's no way she's going to walk 9.6 miles. She'd have to go backwards first. So it looks like we get 2.422. Now, that's our only critical point that makes any sense. That's in our domain, actually, so it's the only possible one. So I'm going to test points around that, 1 and 3. And we're going to find the derivative of t. So if we plug in 1, wow, 1 minus 12, that's positive. Okay, that's going to be negative 6 plus that. That's always going to be positive. We don't have to worry about that. But this is going to be negative 15. This has got to be bigger than 15 to make it positive. But what are we plugging in? 1. So 1 minus 12, that's going to be negative 11 plus 52. 52 minus 11 is 41. Square root of 41, 7 squared is 49. So 7 times 2 is 14. It's going to be negative. So we know it's negative. Plug in 3. I guarantee if we plug in 3, that's less negative. That's even bigger positive. It's going to be positive. So we have a relative minimum at that point. But that is actually going to be the absolute minimum, because if we only have one relative extrema, it has to be an absolute extrema also. So that is the answer to this question.